So we're going to look at calculating distance or displacement from velocity today. And a lot of you have done this before using in your physics classes where you take a look at velocity and you calculate your distance or displacement. And in general, we can say that the velocity times time equals distance. Or we could say the velocity times the change in time is a change in displacement. Okay, if we actually use velocity, because velocity has direction, we can actually talk about that as displacement. So we're going to take that main idea, and that main idea then is that if I have some velocity, for example 10 meters per second, and I do that for 5 seconds, there's my velocity time graph. There's v, there's t, and velocity times time is going to give us our displacement. And notice that the velocity is a length or height of that graph, and the time is the width of that graph, and that is also calculating area. And if we actually work out the units, 10 meters per second times 5 seconds gives us a displacement of 50 meters. So what we're going to use is that property that area underneath the velocity graph actually is our displacement. Okay, so we have a car is traveling, so the velocity is never decreasing, which means it's always increasing. And during a 10-second interval, you've been given different velocities, so it looks like it's speeding up as it's going along. Okay, and we're going to calculate, and we're just going to estimate the displacement based on these velocities and time intervals. So we need to first of all graph that. So I think it's going every 2 seconds, it goes 30, 36. So just going off to the graph here. So we're starting at 30 seconds here. Okay, we're gonna end up at 36 seconds. Okay, just need to get my values here, 40, 48, 40, 48. I think it was 54, somewhere around here. 54. And the last velocity I think was 60. At 10 seconds we're going to be at 60 meters per second. So there it is. Those are my velocities and times. So I'm going to estimate the distance or the displacement here by calculating those areas. And I'm going to do it first with a lower estimate. So I'm going to use a lower estimate in that region for the first 2 seconds. If I use a lower estimate, I'm going to use a time interval of 2 seconds, and my lower value is going to be 30 meters per second. So I know in that region, it started at 30, ended at 36, and the average is somewhere in between, and we don't know what's happening in between, but we're going to say that use the lowest estimate of 30 meters, and so we're going to do the change in time times our velocity is equal to their change in displacement. Okay, and our change in time is 2 seconds. We're going to times that by 30 meters per second, and we get a displacement of 60 meters. So that would be our lower estimate. And that's our best lowest estimate. We know that it can't be lower because it's always increasing. And then if we take a look at our maximum, the very maximum it can be, because we're saying that it's always increasing, so it always increases, so the max must be at 2 seconds. And doing the same thing, the change in time times velocity, the maximum velocity gives us our best upper estimate, so 2 seconds times 36 meters per second, and we get our best upper estimate as 72 meters. Okay, so we know it's somewhere in between. We know it can't be less than 60. We know it can't be greater than 72. And so we could do this for the whole table. Okay, we want to get the best low estimate, and we want to get the best high estimate for all the time intervals. So we're going to just do that for the whole table. You can do that in a separate piece of paper. So I'm going to do my best low estimate in blue. Okay, so it's going to be 60 plus 72 plus 80 plus 96 plus 108. Okay, adding that all up, use my mental math here. 212 it looks like. 212 plus 108 is 310, and so I'm getting 416 meters. Okay, you might want to double check that, but that looks like to be my best high estimate. Okay, 416 meters. So then I'm going to do my best low estimate. Sorry, but that's my best low estimate. Sorry, I made a mistake here. It's because I'm using the lowest speed or lowest velocity in each interval. So that's my best lowest estimate. My best high estimate is going to be 72 plus 80 for the next interval, 96, 108, and 120 meters. Oops, we're going to add those up first. Okay, so it looks like I'm going to have 476. Okay, meters is my best high estimate.